Hello, everyone, and welcome back with the machine learning algorithms that we are building in PySpark and SQL. So now we are going to start another complicated type of the machine learning algorithm, which we call unsupervised learning, and that is a bit complicated than the supervised learning, because in the supervised learning we have the title or the class labels available, so we can use them to train our model, and then we run across the new set or test data or the validation or the unknown data set that we want to predict. However, in the unsupervised learning, like the name mentioned, there is no supervision. We don't have any class level available. Like, we cannot tag the record or the object that what class it belongs to. So that's why it is called unsupervised learning. And then obviously we need to still classify based on some feature set that we can identify, and it depends upon the attributes or the features that we are using into our algorithm. So that's where it is very sensitive to the features that you are selecting. So obviously we need to focus a lot on the feature selection if we want to successfully implement the unsupervised learning and to predict the class of the record, right? And we have multiple algorithms which are available. Obviously, we're gonna see our first algorithm, which is k-mean clustering, and how cluster work. It's the concept is very smart and simple to understand, but obviously the implementation is going to pose a lot of challenges, but we are ready for the challenge, so we're going to implement it in the best possible way to not only learn, but we can adapt it for our day-to-day examples, and we can use it. So first, let's see how the clustering work in the unsupervised learning. So now you can see we have bunch of objects, and consider this part as the data set where every object is mixed with each other. We don't have any class that can, separate red from yellow, from orange to blue. Now we want to classify these objects, right? And obviously we need to find a way that what's the best way for us to categorize these objects. And obviously one thing we can see that there's a color that can be used to classify these objects into different cluster. Like, we can separate the red, yellow, blue, and orange, right? So the same way we normally generate the cluster into our k-means, and obviously by looking at the name means, we use the calculation as mean to calculate the center of the cluster. And K mentioned that how many cluster we want to create. So for example, if I want to classify this data set using unsupervised machine learning algorithm, and I'm going to use the k-mean cluster, that means my k is going to be 4, because I have 4 cluster. So I'm going to divide my objects into 4 different categories, right? And obviously later on, once we get into the algorithm, we'll see what method we are going to use to define these cluster. Right now we just need to understand, in order for us to classify these objects, we need to create the cluster where whatever records or the rows we are combining each other under one cluster, they share the common attribute. That's the most important thing that we need to understand. And how we can identify whether they are sharing or not, that's a very good question. And then we're going to first look at the k-mean clustering functionality, and then I'll show you the mathematical model that will help you to understand. So now first let's look at the k-mean cluster algorithm mechanics. All right, so we'll see how it works. So k-mean clustering classify It's going to be unsupervised. Like I mentioned, we don't have any class level available. It's the example of the unsupervised machine learning algorithm. How it works, it actually divide the number of rows into k cluster or cluster. Like I mentioned, it's a group where these rows collect and share the similar attribute. How we actually create this group? We calculate the center of the group, which is obviously there's going to be a center point, and based on the item within that cluster, we only collect those items which are closer to that point. So that point, we normally call it centroid, and centroid is the center point of the cluster, and we only collect those objects which are closer to that center, right? And then initially, so how the algorithm start, let's go naive. So we have, for example, 10 records, right? So, and we want to classify into three cluster or three categories, right? So our k value is 3. So I'm going to start the algorithm. I have multiple options. I can pick the first three points and then I can start, or I can pick three random points out of my data set and then I can start. In every way, it's going to end up converging. It's going to reach to the point where the centroid or the center points are not going to move any further. So that was the termination point of our algorithm. Like it's going to reach to some point where there's no more change in the centroid with each iteration. So coming back to the algorithm, how we normally do it. So let's, as a first step, we pick 3 points randomly. Let's take randomly, and then we start calculating the distance of each point to those 3 points, which we assume that these are the 3 center of the 3 different cluster. Now, whatever point is closer to any cluster, it will go into that bucket. So for example, our first point is closer to cluster 3. So we're going to put that into cluster 3. And the distance between that point to that centroid or that point that we have picked up randomly in the first iteration, that will determine whether it's going to sit with cluster 3 or cluster 2 or cluster 1. So that way we allocate all the points. So you can see we have our first formation of three points, which might not be very good, but at least we have some sort of grouping, although it's a dirty grouping. And that's why we have the next iteration where what we're going to do, we're going to recalculate the centroid, because now we have 3 cluster. We recompute the center of these 3 cluster, and then we use again these 3 center point to recalculate or recalibrate our data points into these 3 cluster. And this process keep going on until unless there is no change into the point. So as soon as you can see, as soon as these points come closer to their respective cluster, they are not going to move there. We're going to actually reach to a point where everything converges to the local minima, and local minima means that we reach the point where everything is categorized into a right category or right shape. So that's the whole concept of the k-mean clustering classifier, right? So what mathematical model we use for this cluster, you will be surprised. We use Euclidean distance. Our first implementation is going to be one dimension. So we have, one dimensional array where we only have one one dimensional point. And we're gonna, just calculate the simple distance calculation by subtracting that point from the centroid. But as soon as we increase the dimension, so for example, if we have 2-dimensional data, we enter into a Euclidean space. So in the Euclidean space, like I mentioned, in the k nearest neighbor, now you are quite familiar with the k nearest neighbor. We're going to use the Euclidean distance, and Euclidean distance, like you can see on the screen, we're going to use the Pythagoras theorem, and which is we can see is the subtraction of each dimension of a point from the corresponding dimension of the point, and we square it, and at the end we take the square root. So that way we calculate the centroid, and we keep repeating that process till we converge to the local minima. And what does it mean? Again, where we are not seeing any change in the shuffling of the points, to their centroid. So that's all about the k-mean clustering. And now in the next video, we're gonna see the practical implementation of k-mean cluster into our PySpark notebook. Hopefully, it will help you understand the concept, and stay tuned for the practical demo. I'll see you in the next video. Thanks for watching.